Welcome to part 2 of my GameMaker Basics tutorial series. In this video, we're going to work with views and add very basic object movement. So to recap, in the last video, we created 2 sprites, 2 objects, and 1 room. We went ahead and filled that room manually by dragging in our grass objects into the room. And we moved in our hero object. And when we run our game, it simply opens up that grass room, shows us our grass, shows us our hero. We can't do anything else, but there it is. So the first thing that we're gonna wanna do here, for better visibility for you guys and for me, is to make this window bigger. Now, how can we do that? There's lots of ways we can make this window bigger. The naive way to do it is to basically make the room bigger, because the size of the window is basically the size of the room if you don't specify anything else. So right now at the bottom down here, I have a width of 480. If I were to change that to 960 and run the game, the size of our room is double, and so yeah, our window is now double the width. However, that's not really what we want, right? We want the window to be bigger. We don't necessarily want to have a bigger room. We don't want to have to add more objects to our room. We just want to scale things to be bigger. So let's go ahead and set our size back to 480. Enter. And so now the room is back to our original size. So how can we scale the view? Well, with code. And in fact, there is a very simple and easy function called window set size. However, before we get into that, we have to, before we code that, we have to decide, okay, well, where do we write that code? In GameMaker, basically all code resides inside objects. You can't just write it, and it floats out in space. That has to be attributed to an object. And that's okay. That's not a bad thing. It helps us organize our code, makes it easier to read and to understand. Having said that, if we want to write code to make the window bigger, then we want to write that code in an object that makes sense, right? We wouldn't want, like our hero object, it's going to make sense to have the hero have code that makes a move, the hero that code that makes our hero attack, code that makes our hero level up. We want all that code to be associated with the hero and in the hero. The hero object doesn't care about the view. It doesn't care about some random tree that we code. It doesn't care about an enemy so much. No, the enemy is going to have the enemy code. The hero is going to have the hero code. So what's going to have the view code? Well, the view object. So let's go ahead and right click on our objects to create a new object, and we're going to create an object called obj_view, and this object is going to handle our view. It's going to make our window bigger, smaller. If we ever want to add some kind of like camera shake when we take damage, this object would handle that. When the hero is moving around a big field and the camera needs to actually move and follow the hero, well, then that code will reside in this object. Whenever we want to modify the view, we know exactly where to go. We go to this object view object. So another big concept before we actually write our code is events. Basically, before any code is run, it has to be triggered, right? The code doesn't just run automatically or when it wants. It has to be triggered. And that's what events are. They're basically triggers. So when you click on add event here on an object, it basically lists all the triggers that will trigger code to be run. A trigger can be when you press a key on the keyboard. A trigger can be an alarm, which is like after a certain amount of time. A trigger can be a step, which means it runs every single frame basically of the game, continuously. Something can happen when this object is destroyed, or something can happen when this object is created. And that's what we want for now. So let's go ahead and create on the create event. And this opens up our first code editor window. First thing you should know is that any line that begins with two slashes like this doesn't actually do anything. It's called a comment, and basically you can write whatever you want, and it's basically used to write notes to yourself like this. Like you write something in English, something that you understand, and then you write your code. And the purpose of the comment is to explain that code to yourself, so you know what it's doing, so you can be 100% sure you know what it's doing. But for now, we don't need any of these comments right now, so you can go ahead and delete those. So the code that we're gonna want to use, or the function that we're gonna want to use, is a built-in function, and it's called window underscore set size. Very, very obvious name for the script and what it does. Now, this function requires two parameters. If you look down here in this small text down here, you can see that the function says window set size, and then it has a W, comma, H. So basically it's asking for two parameters, and in this case, the W means width and the H is height. Now, how do I know that? Well, I just know that. If you don't know that, what a function wants, you can just middle click on the actual function name, and it's gonna open up that definition of that function, window set size. It gives you a nice little robust description of what this function does, and it tells you exactly what the arguments are meant to be. W is the new width of the window, H is the new height of the window. It'll even give you a code example. Now, this is true of almost all functions in the game, so that's why I always tell people, just read the documentation, read as much of it as you can, because just by reading the description, the syntax, and the examples included in the documentations, you're gonna get like just all the information. Extremely useful. So right now our room, if you double click on the room, it's a size 480 by 270. So we want to make that bigger. So I already forgot the number. What was it? 480. So double 480 is 960. 960. And double 280, right? It was 280? 270. Double 270 is 540. So that's going to make the window size double the size of our room. One thing I forgot to say, after you write a line of code, you want to put a semicolon afterwards. You technically don't have to do that, but it's very, very good idea to do that. This is basically telling the computer, the compiler, that, hey, I'm finished with this line of code. I'm finished with this command. The next thing I write should be on the next line, but it doesn't have to. But regardless, the next thing that I write is going to be another command. The semicolon just explicitly tells the compiler, hey, we are done with this line. And we are done with this with this code. So we can go ahead and save it. And if we run it, what do you think is going to happen? We're going to run it. And our window is kind of still small. Why is that? Well, that's because, remember, we wrote this window set size code inside of this object view object. And this object view object, while we created it, we didn't actually make a copy of it into the room. We didn't actually instantiate it. So we're going to go ahead and back into the room editor so we can see the room. And then if we go back to the resources, we actually have to drag it in the same way that we had to drag in the grass to see it. We have to drag in the view object so that its code actually runs. Now, as you can see, it's a question mark, and that's because we didn't give this object a sprite. And we can, if we want, we can make it look like the hero, but we don't need that sprite. We don't need to see this object, right? Just because it doesn't have a sprite, just because it's invisible, doesn't mean it's not going to run its code. So we can go ahead and leave this having no sprite, because we don't actually want to see this object. We just want it to run its code, and it will. It will run it when it's created, and it's going to be created as soon as this room starts, basically. That's what the create trigger does. As soon as this object, as soon as the room starts, it loads in all the objects, and as soon as the object loads, it's going to run its create code. So now that the object is inside the room, we're going to run the code, run the game, and boom, see, the window is now twice the size. The room is the same size, the same number of pixels, but everything is just scaled to be bigger. So it's nice and bigger and easier to see. Awesome. What if, however, We want the view to be even bigger. Well, we could just go into here and put in a bigger number in here, right? Like 1200. Now it's even bigger. Well, what if we want it even bigger? What if we want the user to simply decide how big he wants his view, right? Because monitors come in all shapes and sizes. People have different resolutions. We don't know what resolutions people are going to have. So I'm sure you've seen in most modern games, you get an option to change the resolution, like in an option screen or something. Now, we're not going to code an option screen right now. However, that doesn't mean we can't give the user the ability to change this window size. So what we're going to do is we're going to introduce variables. We're going to have a variable called base width, and we're going to have a variable called base height. And those are going to represent the width and the height of our window. And the base width that we're going to use is that original number that we used, 480, and the base height was that, 270. And that's how you assign a variable, right? You create a name. It could be literally anything you want, as long as it doesn't start with a number or like a symbol. As long as it starts with a letter, you can literally name a variable anything you want. Obviously, you want to name a variable a name that makes sense. We could name this variable XCVB and it'll work fine, but we're not going to really know what that variable is just off the top of our head. We want to use a variable that is recognizable, a variable name that is recognizable. So you create the name, you then use the equal sign, and then you assign it a value in this case of 480. And instead of using those numbers 480 and 270 in the function, we replace those numbers with this variable. So now whenever the program runs and it sees base width, it's going to know that base width is the same thing as 480 and base height is the same as 270. So when we, click the wrong button. I clicked the debug button. Now when we run our game, it's using those values, and so that's the small window that we had before. But yeah, we want the window to be bigger, right? And the easiest and the smart way to do it is to like scale, by whole numbers. Base width times 2. The asterisk is multiplication in programming, basically. If we do base width times 2, that's the same as 480 times 2. So that's, again, 960, like we had it before. So now the window should be double the size, and it is. And if we put 3 here, it'll be 3 times the size. Beautiful. Nice, big, fancy window. Okay, that's cool, but we're having to change the numbers ourselves. We want the user to be able to change the resolution, the view, on the fly while they are playing. So let's go ahead and introduce another variable called actual view scale, right? And we're going to set it initially to 1. When you create a variable and then you give it a value, at the very start, that's called initializing the variable, basically giving it some kind of default value. So instead of multiplying by these magic numbers, if you will, we're going to use our new variable called view scale. That's cool, but it's just 1, and it's always going to be 1 unless we allow the user to change it. A nice simple way to get user input is the keyboard, right? So let's make it so that when the user hits the letter Z, right, that's going to stand for zoom. So we're going to let the user hit the Z. We're going to then change this view scale when he hits the Z, and then we're going to call this function again with the new view scale value, and the size of the view should change. So I'm going to go ahead and copy this code right here because we're going to reuse it. We're going to go ahead and go back into the object view by double clicking it. We already have this trigger. Let's add a new trigger, add event. Key pressed basically means when the key is, pressed. Key down means when the key is down. Key up is when the key is released. So we're going to use key pressed in this instance, and we're going to go down to where it says letters, and it's going to give you a list of all the letters on the keyboard. We're going to click on Z. That automatically opens up another code editor. We can delete that stuff up there. We're going to go ahead and paste that code a little down here, because remember, we want to modify the view scale variable. So in this code editor where this is being triggered when the user presses Z. So what do we want to happen when Z is pressed? We want view scale to equal view scale, right, plus 1. So basically, if the view scale is 1 when the user presses Z, view scale is then going to equal 1 plus 1, which is 2. Cool, it increased. If you press it again, it'll be 2 plus 1, which is 3. Cool, it increased again. And then, so after that, this line runs, right? Code always goes from top to bottom, left to right. So this is going to happen. And then after the view scale and changes, this line of code is going to happen. And this line of code, as we already know, sets the size of the window. So let's go ahead and run our game once more. The view scale is 1, therefore we have the small window. I'm going to go ahead and press the Z key. Look at that. It got multiplied by 2, the scale. If we press Z again, now it's scaled by 3. Press it again, 4. And if we keep pressing it, it's just going to keep getting bigger and bigger. I'm starting to get black bars because it's trying to scale things, to make it look nice. Oh, it's just getting bigger and bigger and bigger. But that's actually not great, right? We don't want to be able to make the window just insanely big. We want to have some kind of limit. Let's say after the user scales it 3 times, let's go ahead and cycle back to the initial one. Awesome. A perfect opportunity to introduce a very simple condition, right? We want to check a value, and then depending on what that value is, we're going to want to run some code. The very most basic conditional statement is, of course, if. If, as you notice, when I typed it, turned yellow. If a word turns yellow or orange, it means it's a keyword. In a keyword, well, it means it's a keyword. It has a special function. In this case, if, and then you can put parentheses, if the view scale is greater than 3, we're going to want to run some code that resets it. So basically, we're going to set view scale back to the initial value of 1. And that's all it is. This caret symbol, hopefully you recognize that from math class, equals, greater than. That's greater than, and then this symbol is less than, and then this double equal sign is checking if the values are equal to each other. So right here, we're just checking if the view scale is greater than 3. That means if it's 4 or 5 or whatever, go ahead and reset it to 1. And simply by having those 2 little lines of code, we've just implemented a little limiter. So if I press Z bigger, okay, that's at 3. If I press it again, it's going to be 4, which means it gets reset back to 1. So now the view can't get super big. It stays within our 3 scale values. Isn't that amazing? Before we end this video, though, I want to just very quickly add just the teeniest bit of actual, gameplay. Modifying the view is important, but it's not very fun. So let's very quickly go into the object hero object, and we're going to add another trigger for this object. Well, it's first trigger. And in this case, we're going to go ahead and go into the key pressed trigger again. And we're going to go on the right. Right basically means the right arrow key. So basically when the right arrow key is pressed, well, in this case, I want the hero to move to the right. Now, what does that actually mean, to move to the right? Well, if you go back to, if you remember your geometry classes, GameMaker and GameMaker rooms are basically using X and Y values. If I click on this hero, you can actually see its X and Y values. Well, you can see the X and Y values of my mouse. Right now, the mouse is located at 169 and 138. That means its X value is 169 and its Y value is 138. As I move the mouse to the right, you'll see that my X value is increasing, 186, 190. If I move it to the left, it's decreasing. And as I get to the very left edge of the room, it actually goes down to 0. And if I move it up, same thing, but with the Y coordinate. If I go to the very top left, it's 0, 0. And if I go to the very bottom right, that's the max value to this room. So basically what I'm trying to explain is that if you change an object's X value positively, it's going to be moving to the right. And if you make its X value smaller, it's going to be moving to the left. And with a Y value, if you increase, it goes down. And if you decrease, it goes up. So let's go back into our hero key press right trigger. Every object has a built-in functions, and one of those are X and Y. If when you type a word and it turns green, that means it's a attribute, a built-in attribute of the object, right? If I type in speed, it'll turn green. If I type in image scale, whoops, if I spelled it right, it's gonna turn green. Or not. Oh, that's because it's X scale. It turns green. That means it's a built-in attribute of this object. And what attribute do you actually want to change when we're moving right? Well, like I said, it's the X. So we're going to do X equals X plus 1, just like the view. We want to increase the value by 1. And that's it. That's all I got to do. If we go ahead and run our game, increase the scale a bit, and now I'm going to press the right key, you can see that our hero is moving right. Every time I press the right key, it moves over 1 pixel to the right. And that's it. If I push up, down, left, it doesn't do anything because we haven't coded it. But I just wanted to show quickly how you can move an object using user input, right? We have a trigger on a keyboard key, and we're modifying the object's X value. And by modifying its X value, we can simulate movement. It's very jerky and very small, but it's a start. And I think that's it what we're going to cover for today, views and very basic movement. On the next video, we're going to definitely improve on this movement code so that he moves smoother and in a more fun way. So again, like always, if you enjoyed this video and you found it helpful, go ahead and hit that like button. Thanks for watching, and I will see you next week.